said number 2 and 3 at the
Yeah.
top there? Okay. So the limit as, I'm going to do it to the left here. So this one is the limit as h goes to 0 of the natural log of e plus h squared minus 2 all over h. Does that, doesn't that kind of look like, doesn't that remind you of the limit as h goes to 0 thing that we've done before?
Yeah.
Where you do f of what, x plus h minus, is it f of h or something like that?
F of x. F of x minus plus h minus f of x.
Plus a, not, yeah, I think it's plus a,
Oh, okay.
right? Or something like that.
I think so.
Do you
Let me
have that?
see.
Yeah, look for your notes on that. That was back the definition of limit. Oh no. Um no, it was f of x. Yeah, no, it was f of x. I was right. This is f of x, but this is when x equals, you can see it's when x equals
H, right?
e.
Something.
Exactly. It's when x equals e. So you can see that this function, do you see how the function is the natural log of something squared? So you can see that this is kind of like your function right there. If you got rid of the plus h part, right? Because that's right. That's what this should be. Not plus a, it's plus h. It's what I had in the first place. Okay.
Yeah.
So look at that basically, and then just take out the h part, and then put an x here, and that's probably your f of x. It's almost always how it is. And so when you plug in, like when you plug in e right here, what's ln of e squared equal
Is
to?
2.
Yeah, it's equal to 2. Right? So that's kind of like the formula for it. So what you remember what this whole thing is? This is f prime of x, basically. That's what this formula is. So this is the derivative of that function, the f of x function up there. So your f of x was ln of x squared, which means your derivative is equal to that thing right there. That's your derivative. And what does the derivative mean? It means you're finding the derivative at 2, right? Because we're plugging in 2. So I'm sorry, at e, because you're plugging in e. So b is the right answer. So there's your function, and you're plugging in e. Does that make sense?
Yeah, that makes sense.
Again, practice with that one. Practice is imperative. Just find some more examples like that, so that you get the hang of how to do that right there. And then when you're on your test or the exam, you're taking a quiz or a test or the AP exam even, you identify that as, oh, I've seen this problem before. This is that one problem where I basically just get rid of the H and I plug in an X where that is, and that's probably what I plugged in for X. X equals E. You get what I'm saying?
Yeah.
And this is F of E. Okay. So number 3 says find the equation of the tangent line to the graph So again, what's the tangent line to a graph? What's that mean? When you see tangent line to the graph, what are you thinking of?
I wasn't going to do that.
Oh, you weren't. Okay.
Yeah, I know how to do that.
Okay. Yeah, that just remember tangent line is always derivative. What about on
Right.
this bottom one? Which one?
Um,
Oh, look, here's some more
let's
examples. Let's do these.
yeah, these ones I'm just confused how you like
So it's that same thing. Remember we were just talking about? It's that same thing.
find these.
See how this is that same format? So this thing right here, take that minus out of this, and that would be 3x to the fourth minus 2x plus 1. See what I did there? I distributed that negative 1 out. Because again, look at the formula. See that formula that we started with? The formula's
Yeah.
got a minus in it. Do you see it there?
Yeah.
So, whoops. Shoot, I do that. Oh, do that sometimes. My bad. You back with me? Can you see my screen now?
Yeah, I can.
Okay. So that means that this is your function. This is your f of x right here. And you can see that that's what they did here. They plugged in f of x plus, this is f of x plus h. To see for all the x's, they plugged in x plus h. So evaluate the limit. Well, this is just the limit. This is just the derivative of that function. So your function, y equals 3x to the fourth minus 2x plus 1. So what's the limit of that? The derivative of that? Just use the power rule. 12x cubed minus 2. Got it?
Okay.
That's the easy way to do it. You could do it the long way by simplifying that whole thing algebraically, but it's better if you recognize, oh, look, that's that one limit that we talked about. Now, all of these, this is, yeah, all of these three are using the different definition. Do you remember the other definition? It was the
F of
limit.
x minus f of a or something.
Yeah, it was the limit as x goes to a of f of x minus f of a all over x minus a. So this is the other definition of the derivative, right? See, that's
Yeah.
whoops, slightly different. So for that definition, again, what is your derivative? Your f of x is going to be this one right here. That's your f of x. So f of x equals secant of x. And what are we evaluating at? We're evaluating it at x equals pi over 3. So what's the derivative of secant x? Look up your formula sheet. What's the
It's
derivative?
like secant x tan x, I think. Yeah.
I don't know it. I'm trusting you.
I'm pretty
So
sure
then
I believe that's what it is. I'm like 99% sure that's what it is.
sounds right. Seems right. So then what would this limit be? Well, that's the limit as what is your value? That's asking for the derivative at pi over 3. So now I'm plugging in pi over 3 into here. So what's the secant of pi over 3? The secant of pi over 3 is 2. And what's the tangent of pi over 3? Do you remember these? Remember trig?
Tangent of pi over 3.
So remember
It's like
the cosine was 1/2
yeah,
and
it's
root
it's
3
like
over 2.
3. It's like square root of 3.
Yeah, so the tangent is the sine over the cosine, right? So it's root 3 over 2 over 1/2, which is just root 3. So there's your answer, 2 root 3.
So
Yeah,
what I'm confused about, and this isn't really part of this question. It's not like it's not there like on the paper, but there'd be a question about like it'd be a question to the effect of like, oh, the function is evaluated, the function f is evaluated at some value c, find f and c. And the function is just like kind of what we're doing with like secant x and like 3x 4 to the 4 minus 2x plus 1. But what would c be?
C is just some value of for X. C is just it's just another it's like a variable. It's a specific they're just saying find the value C. Usually in calculus they use C to be in between A and B. Like A and B is your interval and C is somewhere in between it. Like you're going to use that a lot in the future. But sometimes C can just be used as a or it could just think of it as any constant. C is just any constant. Do you have an example I can see of what you're talking about?
Uh, Let me see. Yeah, I should.
Real quick, number two, this is just the derivative. So this is just the generic derivative, right? So this is
Yeah.
just the derivative of sine, which is cosine. And this is just the derivative of um, the function x to the 1/3. That's your function. So the derivative of that is just 1/3 x to the -2/3. That's just your answer there.
Okay, so it's let me take a screenshot and then from like
You want me to do this number 11 real quick for you?
sure.
Okay, so for number 11, what we're going to do is we are going to rewrite these so that I can use the power rule. So that's 1/3, and this is x to the -5th. So that's your f of x, right? So what's your f prime of x? What's your derivative? Just use the power rule. 6 times 1/2 is 3, subtract 1. Bring the 1/3 down, subtract 1. Bring the -5 down, subtract 1. That's it. Okay.
Okay.
Do you see how I did that? Make sense?
Yeah.
For this, for 18, find the value of both m and b that make it continuous and differentiable. So we've done these before, you remember? This is to for it to be continuous. Oops. For it to be continuous, what you would do is you would these would have to be equal to each other. X squared plus bx would have to equal mx plus b, right?
Yeah, the derivatives of those would have to equal.
Yeah, exactly. So you remember doing this?
Yeah.
And for it to be differentiable, you take the derivatives. So it's 2x plus b and then m. And so those have to be equal. 2x plus b has to be equal to m. So now I have a system of equations, and I can just solve the system of equations by um, I'm sorry, I did that wrong. This is at 2. So I'm going to plug in 2 for all of these. So 4 plus 2x equals 2m plus b, right? They have to be equal
Yeah.
at that value, right? And then this one is going to be 4, whoa, 4x plus b equals m. Whoops, 4 plus b equals m. So m equals 4 plus b. Plug it back in. Sorry, I put an x there. I should have put a b there. So simplify this. Let's see. 4 4 plus b, I subtract to b equals 2m. That's one equation. Then 4 plus b equals m. How about that? That means m has to equal 0. So m equals 0, which doesn't really make a ton of sense. Well, I guess it could make sense. And that means b equals -4, if I did that
Yeah,
right.
yeah, you did.
Okay. My battery's almost dead. What was your other question? Oh, I got it.
Over here.
Yeah, I got it. Okay.
You can just do one and 8 and 9 if the battery is almost dead.
8 and 9. Okay. So
Yeah.
the limit as x goes to 1 of this. So I'm going to factor this first.
Yeah, these are the F and C questions also.
Yeah. So remember you remember this from here, hold on. Let me just plug in I can just plug in my charger real quick so we don't lose this. I have 5% left, but I don't know how quickly it's I had 15% at the beginning and I thought I had plenty of power, or maybe I just don't. Maybe my battery isn't as hardy as I thought it was. So do you remember doing rational functions before?
Um, I think so, yeah.
Okay, so this is a rational function. So let me just give you the visual for this. This equation, if I just took x squared y equals x squared minus 1 all over x minus 1, that's a rational function, not equation, rational function. And so it's got like maybe it has asymptotes or holes, or you remember that doing that before? And what you would do to find those is you would factor first. And if you can cancel something, which you can in this case, see, you can cancel the x plus 1 or x minus 1 on the top and bottom. You with me?
Yes.
Okay. Do you remember doing this before? That means there's a
Yeah.
removable discontinuity or a
Oh, yeah,
hole
it is. Yeah,
at
it is.
1 at x equals 1. So, and if x equals 1, then I plug 1 into the remaining. So that this just equals x plus 1. So there's a hole at 1 comma 2. So really all this is, that's just a line. This is nothing more than just a line with a hole in it, because it's just the same as x plus 1, except there's a hole at 1 comma 2. So at 1 comma 2, there's a hole and it's a line x plus 1 like that. So that's what that function is. Okay, so the question is asking, what's the limit as x goes to 1? Well, look at this, jump on the graph here. As you're going to 1 from the right or the left, what would you expect the value to be at 1?
Two?
Yeah, you'd expect it to be 2. Is it 2? No, it's
No.
not defined at 2, but you would expect it to be 2. So that's what that question is getting at. So however they worded it, they're basically saying what at what value, um what would you expect? Well, I don't know. I don't know how they worded the question. What did they say?
Says in problems 8 to 13, each limit represents the derivative of a function f at some number c, determine f and c.
Okay, well, say the last part of it again.
Determine f and c.
Oh, okay. Say it slower right before that. What are F and C? What did it say right before that?
The derivative of a function f at some number c.
Okay, derivative at some number C.
Yeah.
Okay, so C is your, yeah, C is um yeah, I don't, I'm not, I'm trying to think of why it said it like that. Look at number 9. Can you see what number 9 is? If I factor
Yes,
out
your
a negative
free.
1, it'd be 3x squared plus 2x minus 5. That's
Yeah,
your function. That's your f of x. 3x squared plus 2x minus 5. And so they're trying to find the limit as x goes to 0. So they're basically asking what's the derivative at 0, right? That's what they're saying. Oh, and I guess that's what this is saying too. And if you think of it like that, if you think of it as this is something squared, that's your function. It's x squared. Because this, you could see that you could think of that as um, the limit as x goes to as x goes to 1 of f of x minus f of a all over x minus a. That's what they're doing. And a equals 1. F, f of x equals this, and a equals 1. That's what they're doing here. So they're really not doing what I was showing you here, although it does work that same way. They're basically, the other way to do this problem is to say what's the derivative of x squared? What's the derivative of x squared? 2x.
2x.
And what is f prime of 1? What's the derivative at 1? It's 2. They're doing basically the same thing, but they're using derivatives instead of rational functions for it. Got it? So for number 9, take the derivative of this, 6x plus 2, and now plug in 0. So it's 2. Got it? So
Yeah.
number 10, what's number 10 saying? What's the function?
Um, 4? I don't know.
Remember, let's use that.
Two?
Let's use that formula. Remember, it's that squared. So it's y equals x squared, I believe, right?
Yeah.
Because what's minus 4? That's 2 squared. So right, remember that formula I was telling you about? The limit as h goes to 0 of f of x plus h minus f of x all over h. So that's what they did. They did that at x equals 2. This is at x equals 2. Um, right? This is so my f of x, this is my f of x. Whoops. This is my f of x right here. And I'm doing it at x equals 2 because you can see that that's 2 squared right there. Make sense? So the answer to this question, y equals x squared, what's the derivative? 2x. And what am I doing it at? At what value? I'm doing it
2.
at x equals 2, which is 4. So my answer there
Okay.
is 4. Now number 9, I'm having second thoughts about number 9 now. Number 9, I don't know that they gave you a value to do it at, right? Because see, look at number 9. See how they're just giving you your x? They're giving it to you in terms of x. So I don't know that it's at 0. The limit as h goes to 0, it's always limit as h goes to 0 when they do it like that. So I feel like the answer for that is just maybe 6x plus 2 because they didn't give you a value to check it. You get what I'm saying?
Yeah.
Do you have the answer key for that?
It says, yeah, it says for 10, it says f of x equals x squared. C is 2.
Yeah, C is 2, right? C is 2, right? That's this. And so the value is 4. But how about for number 9? They didn't
Number
give you a
nine,
C.
number nine C is x.
Right, exactly. So they didn't give you a C. They just wanted they wanted the generic formula without the variable. You get what I'm saying?
Yeah.
So here's a summary for you. Do you remember those two formulas you had? The one
F of
formula was
x
the
plus
limit.
h.
Yeah, the limit is h goes to 0 of f of x plus h minus f of x all over h. That's one of them. And the other one was the limit as x goes to a of f of x minus f of a all over x minus a. And these are both formulas for what? The derivative, right?
Yes.
And what is the derivative after all? The derivative is the slope of the tangent line, right? The derivative is just a slope. And what's the formula for slope? Do you remember from algebra 1? It's
Um,
rise
rise over
over
run, yeah.
run. And what's the rise again? Y2
Uh,
minus
y1,
all over.
x2 minus x1.
Hey, look what I have here. What's f of x minus f of a? It's the same as y minus y. And what's x minus a? It's the same as x minus x. This is your rise, and this is your run. That makes sense?
Yeah.
Also, this is your rise, and your run, this is your run. Because why is it your run? Because what is h getting closer and closer to? It's getting closer and closer to 0. So what are we doing? Now, do you remember the picture I showed you before? What is the derivative of something? Let's say I have this, let's say I have this parabola right here. Okay. See my parabola?
Yeah.
What is the derivative at, let's say, 4? What's the derivative at 4 mean? What would I do for that? What am I trying to what does the derivative mean ultimately? What's
Slope
the
of the
derivative?
tangent line.
That's right. It's the tangent line, right?
Yeah.
So here's my tangent line. And a tangent line has a what? It has a rise and it has a run, right?
Yes.
So what you're doing to find that rise and that run, look at what your formulas give you. What you're doing, let me change the color here, is you're taking an arbitrary point, let's say for this one up here, and I'll do this in green, you're taking an arbitrary h right here. This is your h right here. So if that's my h, what's happening to the h? What am I doing to this value of h? I'm finding the limit as it gets what? Bigger or smaller?
Bigger.
No, look at it. I'm finding the limit as h goes to what?
Okay, let me see.
0. Finding the limit as h goes to 0. That's what you're trying to do. So what does that mean? Well, I'm taking, can you see it okay? Let me zoom in.
Yeah.
Here's what I'm doing. I'm taking this line right here. This is I'm finding the slope of that line, but then I'm making it smaller. Then I'm saying, okay, now let's make h smaller. So now h is here. or now the f of x plus h is here. And now see what's happening to the slope of that line? What's happening to it? Now I'm going to make it even smaller. Here's my new h. H is getting smaller each time. You get what I'm doing? If
Yes.
h is getting smaller, what is this line eventually going to become? What is this line going to end up being? Just the tangent
This,
line.
yeah.
It's going to be the tangent line because it's so small that h is so close to x or to 4. It's so close that it's just right on top of it. That's what you're doing. That's what you're doing with calculus. That's what calculus does. So that's one way you can think of it. The other way you could think of it, I'll do that in purple. You're taking the rise and the run, and you're instead of using h, you're using x and you're using a, and you're making here's x right here, and here's a right here. It's the same concept, just written in a different way. And what are you doing with x and a? What's this the limit of? It's the limit as x does what? The limit as x gets closer to a. What does that mean is happening with these two things? If x is equal a, what does that mean? That they're going to be right next to each other,
Yeah.
right? So it's that same concept. You could think of it as h goes to 0, or you could think of it as x goes to a. Got it? So it's either h goes to 0, which means h is getting closer to x, or x minus a, or x goes to a, which means a is getting closer to x. Either way, it's getting closer and closer and closer. And what are you finding? You're finding the slope of the tangent line. That's what both of these equations do for you. So if you're ever like can't remember what the formula is, just remember rise over run. It always has a rise over a run. And it's the limit as that denominator is getting closer and closer to 0. That's what you're essentially doing every time.
Okay.
Okay, makes sense.
Yeah.
Hopefully that clears it up for you. But now, if you go back and you look at all the stuff that we did, you'll see, oh, that's how this is all related to each other. Like you look at this formula, this number 2 here, and you're like, oh, I can see it. I can see that rise over run now. Can you see what I'm talking about? Here's your
Yeah.
rise, here's your rise, and here's your run. Oh, this is something minus something else. That's like y minus y, and over your run, which is just 0. It's going to 0, right? Or the second one, there's your if you can visualize, if you can see it, it's not that really hard to see if you can recognize, oh, there's my first thing and there's my second thing, and they're being subtracted. There's my rise and my run is h. Same with here. Here's my rise and here's my run. This minus this. And you recognize it, and then you start to see they're all just the same kind of thing.